Hello and welcome back to the Core Learning channel. Today we're going to be looking at manipulating surds. So the first question we need to ask is, what is a surd? Well, a surd is simply an expression with an irrational square root. So this means it's a number that can't be expressed as a fraction. So let's have a look at what this actually means with an example. So a surd would be something like root 2 or root 3 or root 5. So these don't have nice integer values or even fractional values. Whereas if we had something like root 4 or root 9, this would be 2 or 3. These can be expressed quite nicely. So we're going to look now at a few rules that are really important when we're going to be manipulating surds. And the first of these is how to multiply surds. So the rule for this is root a times root b is equal to root a times b. With a few examples, this is what it would look like in action. So root 2 times root 3 would be root 2 times 3, which would be root 6. Root 3 times root 5 would be root 3 times 5, which is root 15. Root 7 times root 11 would be root 7 times 11, which is root 77. Or root 4 times root 5, which would actually be root 20, but we can actually make a simplification here because root 4 is just 2. So this would be 2 root 5. Now, I'm going to go through a proof for this, and the reason is, as will often happen, if you're in an exam situation, there are a lot of rules to remember, and sometimes you can just forget. I find that I'm much less likely to forget if I'm confident in my abilities to derive a rule if I do become stuck. So the way I'm going to do this is we first have to look at the rule we're trying to prove. So you get a question and it's the thing you need to do is that you need to work out what root a times root b is, with obviously integers instead of a and b. And you think, oh, I can't remember what the manipulation for this is. Well, what you do is you start with this, and we're going to put some integer values in. In this case, I'm going to go with 9s. So why am I doing this? Well, I'm going to put 9 in place of the a and the b, and I'm going to try and derive the rule by using 9 because 9 has a nice square root. The square root of 9 is 3. So we can get a nice integer value for this. And then what we're going to do is we're going to compare it to a root term, and we're going to try and derive the rule that way. So I know that root 9 times root 9 is 3 times 3, which is 9. So now that I have this, I want to try and rewrite this answer in terms of a root. Well, 9 is equal to the square root of 81. What this means? Well, root 9 times root 9 is equal to 9, which is equal to root 81. So we have root 9 times root 9 is equal to root 81. And what we're going to do, if we look at this root 81, we can actually rewrite this as root 9 times 9, which means we have that root 9 times root 9 is equal to root 9 times 9. So going back to a more general formula, by comparing the left-hand side to the right-hand side, we can see if we're to write the 9s in terms of a and b's again, we would have the rule being root a times root b is equal to root a times b. So similarly, we're now going to look at dividing surds, and we're going to go through a similar process to try and derive the rule. So the rule itself is that when we have root a divided by root b, this is equivalent to the root of a over b. And again, I'll run through some examples so you can see this with some number terms attached. So for example, if we had root 6 divided by root 2, this would be equal to the square root of 6 over 2, which is root 3. Or if we had root 8 over root 2, this would be equal to the square root of 8 over 2, which would be root 4, and root 4 is just 2. And the last one we have is root 5 over root 3. This would be equal to the square root of 5 over 3, and this can't be simplified any further. So like we did before, How are we going to prove this? Well, we're going to use exactly the same method as we did previously. So again, I'm going to use nines. So I'm going to take root 9 over root 9, which is equivalent to 3 over 3, which we know is equal to 1. How would we express 1 in terms of a root? Well, 1 is just equal to the square root of 1. So we have that root 9 divided by root 9 is equal to 1, which we know can be expressed as root 1. And how can we express 1 in terms of nines? Well, root 1 is the same as root 9 over 9. And now comparing this left-hand side to the right-hand side, we have root 9 over root 9 is equal to the square root of 9 divided by 9. And again, putting the a and the b back in place of the 9s to make a general rule, we have that root a over root b is equal to the square root of a over b. So now let's do some practice on multiplying and dividing surds. So here are the questions. Pause the video, have a go at these questions, and when you feel ready, unpause the video and we'll go through the answers. So hopefully you found that okay. So let's jump into the first one. We have root 2 times root 5. So using our rule, this is going to be equal to root 2 times 5, which is going to be root 10. Next, we have root 3 times root 6. So this is going to be root 3 times 6, which will be root 18. We have root 10 over root 2. This is going to be root 10 over 2, which is going to be root 5. And lastly, we have root 20 over root 5, which is going to be root 20 over 5, which is root 4, and root 4 is equal to 2. So the next bit we're going to look at is adding and subtracting surds. So this is actually quite simple. If we have root a plus root b, we can't simplify any further. We just keep it as is. Likewise, if we have root a minus root b, we can't simplify. This is just root a minus root b. So I know this seems a little bit simple, but just to show some examples anyway, just in case this is confusing. If we had root 2 plus root 3, this is literally just root 2 plus root 3. There's nothing we can do to this. This is as simplified as it can be. I'll put the others up on the screen. You can look at those more closely, but you know what the rule is. So the next bit we're going to come to now is something called rationalizing the denominator. So what is rationalizing the denominator? Well, quite simply, if we have a surd in the denominator, i.e. the bottom of the fraction, usually that's going to be quite inconvenient if we're trying to do any kind of manipulation. So when we're writing out an expression, it's generally quite useful to try and remove the surd from the denominator. So this is what we mean by rationalizing the denominator. So there are several types of problems that we can have. So usually this will be something like a over root b, or we might even have a over b plus or minus root c. So if we have a problem of the form a over root b and we're asked to rationalize the denominator, how would we do this? Well, quite simply, we can just multiply top and bottom by root b. And this is something I probably will cover elsewhere, but the reason we can do this is that root b over root b is just 1. So it doesn't change the value of that expression at all. We can always just multiply something by 1 because it just returns the same answer, doesn't it? Which is why we can multiply top and bottom by root b. If we do this, this is going to give us a times root b on the top, and on the bottom, a root times a root, or root b times root b, is just going to be b. So you can see that the surd has moved to the top, and we no longer have a surd in the denominator, which I've written here. So now we're going to look at the second type of problem, and there are several identities we can actually use to do this. The first of which, we have a plus root b squared. So this is going to be a plus root b times a plus root b. When we expand this out, we get a squared plus a root b plus a root b plus b. An important thing to note here, this is a squared at the start, but only b at the end. And the reason for this is that it is root b squared. Root b squared is just b, but obviously a squared is a squared. So when we simplify this, we get a squared plus 2a root b plus b. And now the next one is really useful for the type of problem we have at the top. And this is a plus root b times a minus root b. Now this gives us a squared plus a root b minus a root b minus root b squared. Now the two middle terms here, the a root b's, you can see these cancel out. So what we're left with is a squared minus b. Now, if you're paying attention, you might be able to see how this is going to be quite useful for dealing with the type of problem we have above. So I'll move on to the next slide where I'll show why this particular identity is very useful. And here I've just written out the rules more explicitly so you can see them and use them if you need them. But yeah, as I say, we'll move on and I'll show why this second identity is so important when we're trying to deal with this type of problem where it's a over b plus or minus root c. So when we have this type of problem, what we can do is utilizing the fact that when we have b plus root c times b minus root c, we're going to get b squared minus c. Now, given that b and c are both going to be integers, b squared minus c just gives us an integer. So this is going to completely remove that root c term that we don't want in the denominator. So I've written this here. So we have if a over b plus or minus root c, then what I want you to do, I want you to work out or write down separately this same denominator that we have, so the b plus or minus root c, but whatever sign it has, you're going to write the opposite sign. So if it's b plus root c, then you're going to write out b minus root c. And if it's b minus root c, then you're going to write out b plus root c. Just to be clear, I'm not saying to actually change the denominator itself. I'm just saying, first of all, we want to work out or duplicate this, but with the opposite sign in the middle. And just to be clear, just in case you've never seen this before, where we've got this plus on top of a minus, and then on the other side we have a minus on top of a plus, then this just means what I've said here, which is when the denominator is b plus root c, then I want you to work out this term with a b minus root c, and vice versa. So what we're going to do now is we're going to multiply top and bottom by this denominator term that you've just worked out, but obviously with the opposite sign. So let's imagine that we have a over b plus root c, then we'd multiply top and bottom by b minus root c. And the purpose of this is, obviously as I've just said, we worked out that when we have b plus root c times b minus root c, this is going to give us b squared minus c on the bottom. When we work this out on the top as well, we're going to get ab minus or plus a root c. And this will eliminate the surd from the denominator. So we'll now run through some examples so we can actually see this in action. So the first one we have 2 over 2 plus root 3. So what I'm going to do, I take that denominator and I say, well, that's 2 plus root 3. So I'm going to work out that, but with the opposite sign. With the opposite sign, this will be 2 minus root 3. Now what I'm going to do is multiply the top and bottom of the fraction by this 2 minus root 3. So I have 2 times 2 minus root 3, and then 2 plus root 3 times 2 minus root 3. So on the numerator, this is going to be equal to 4 minus 2 root 3. And then when I work out the denominators, well, I know that it's going to be b squared minus c, and my b in this case is 2. So b squared is 2 squared, which is 4. and then I have root 3 times root 3, which is just 3. So I have 4 minus 3. So in total, that gives me 4 minus 2 over 2 root 3 divided by 1, which is just 4 minus 2 root 3. Next, I have 5 divided by 4 plus root 7. So again, I take the denominator, I have 4 plus root 7, rewrite it with the opposite operator in the middle. So I'm going to multiply top and bottom by 4 minus root 7. Multiplying this out on the top gives me 20 minus 5 root 7, and on the bottom 16 minus 7. Simplified, this is 20 minus 5 root 7 divided by 9. Next, we have 3 divided by 10 minus root 6. So that denominator, 10 minus root 6, I want to multiply top and bottom by 10 plus root 6. Doing this, I get 30 plus 3 root 6 divided by 100 minus 6. And that gives me 30 plus 3 root 6 over 94. The last one I have here is 1 divided by 2 minus root 8. So that 2 minus root 8, I want to rewrite as 2 plus root 8 and multiply the top and the bottom by that. So doing that, I get 2 plus root 8 over 4 minus 8, and that's going to give me minus 2 plus root 8 over 4. So now let's practice some questions yourself. So I've put the questions up here. Obviously, just pause the video, have a go, and then when you're ready, unpause the video and we'll go through the answers together. So hopefully you found that okay. So let's run through the answers. So we have 1 divided by 2 plus root 3. So how are we going to do with this? Well, our denominator is 2 plus root 3. So what we're going to do is we're going to multiply top and bottom by 2 minus root 3. So I'll just put the answer up there. When we do this, we get 2 minus root 3, and then on the bottom we get 4 minus 3. Simplified, this is 2 minus root 3 over 1, which is 2 minus root 3. Next, we have 3 divided by 1 plus root 3. So we're going to have our denominator term, so we're going to multiply top and bottom by 1 minus root 3, and that is going to give us 3 minus 3 root 3 over 1 minus 3, and that is going to be equal to 3 minus 3 root 3 divided by 2. Moving on, we have 6 divided by 4 minus root 2. We're going to multiply top and bottom by 4 plus root 2. That's going to give us 24 plus 6 root 2 divided by 16 minus 2. That's going to be equal to 24 plus 6 root 6. That is incorrect. That is 24 plus 6 root 2. I apologise. 24 plus 6 root 2 divided by 14. And we can simplify this as we can divide each term in here by 2. So we're going to have 12 plus 3 root 2, not root 6, over 7. Lastly, we have 4 over 5 minus root 8. We're going to multiply top and bottom by 5 plus root 8. When we do this, we're going to get 20 plus 4 root 8 divided by 25 minus 8. This is equal to 20 plus 4 root 8 divided by 17. So there are no more rules to know. Now it's time to have a look at some questions. So I've provided a mix here of some different style of exam questions, which are going to utilize a number of the different rules that we've gone over today. So the first question we have is to express 5 over root 2 in the form a root b, where a and b are positive integers. So pause the video and then unpause the video when you're ready, and we'll go through the answer. So hopefully you found that okay. Let's have a look how we would solve this. So as we said, we just need to multiply top and bottom by the surd term that we have in the denominator. So we're going to multiply this by root 2 over root 2. Doing this, we get 8 root 2 over 2, and this is going to be equal to 4 root 2. So question number 2, we have rationalize 10 over root 5. So remember, when we say rationalize, all this means is get rid of that surd term in the denominator. So pause the video when you're ready and unpause it when you want me to go through the answer. So now we'll run through the answer to that. So as we did previously, you just have to multiply through by the surd term. So we have 10 over root 5 and we're going to multiply top and bottom by root 5. This is going to give us 10 root 5 over 5, which in its most simplified form is 2 root 5. So the next question we have, expand and simplify root 2 plus root 6 squared. And I want the answer in the form a plus b root 3. Okay, we'll jump into the answer. So first step is let's rewrite this with 2 brackets. So we're going to have root 2 plus root 6 times root 2 plus root 6. Now we're going to expand out the brackets. So our first term, we have root 2 times root 2. Our second term, we have root 2 times root 6. We have root 2 times root 6 again. And our last term is root 6 root 6. So now we can simplify using the multiplication rule. So we have root 2 times root 2 is root 2 times 2, which is root 4, and that is 2. We have root 2 root 6 plus root 2 root 6. So this is 2 lots of root 2 root 6. And then on the right hand side we have root 6 root 6, which is root 6 times 6, which is root 36, which is 6. So we'll just tidy that up a bit and we get 8 plus 2 root 6. And then there's one last step we can take here. And that is that we have this root 6 term. So this root 6 term we can rewrite using the multiplication rule as root 3 root 2. When we do this, we now have 8 plus 2 root 2, and then we're going to sub in that root 2 root 3 instead of the root 6. So we have 8 plus 2 root 2 root 2 root 3. And we can simplify this root 2 times root 2. So root 2 times root 2 is 2. So we would now have 8 plus 2 times 2 times root 3. 2 times 2 is 4. So this is 8 plus 4 root 3. We have a similar question next, but a little bit different. So we have expand and simplify 3 plus root 8 times 3 minus root 8. So again, pause the video and come back when you're ready to hear the answer. So hopefully you got on with that fine. Let's have a look how we would work this out. So let's expand out the brackets. So our first term is 3 times 3. And then we have a plus 3 root 8 term. And then we have a minus 3 root 8 term. And then we have a minus root 8 term. So working this through, obviously 3 times 3 is 9. The two middle terms, the 3 root 8 terms, they cancel out. And then we have a minus root 8, and root 8 times root 8 is going to be just 8. So this is 9 minus 8. So our final answer is just 1. Moving on, we now have question 5. So I want you to write root 20 plus 3 over root 5 in the form a plus b root 5. So pause the video and come back when you're ready to hear the answer. Fantastic. Hope you found that okay. So how do we work this out? Well, we're going to use the rule where we can multiply the top and bottom by the same surd. So in this case, we have a root 5 on the bottom, so we want to multiply top and bottom by root 5. When we do this, we get root 20 times root 5 plus 5 root 5. and this is divided by root 5 times root 5, which is just 5. We can simplify this, so root 20 times root 5, that using the multiplication rule can be expressed as root 100. And then we have the plus 5 root 5, which can't be simplified over 5. So simplifying this, the root 100 is just 10. So we have 10 plus 5 root 5 over 5. And now we have a 10, a 5, and a 5, all of which can be divided by 5 to just give us 2 plus root 5. Next, we have question 6. So I want you to write root 700 plus root 28 minus 2 root 63 in the form a root 7, where a is going to be an integer. So pause the video and come back when you're ready to hear the answer. So how do we work this out? Well, what we're going to do is rewrite each term in terms of root 7. So using the multiplication rule, we know that we can rewrite root 700 as root 100 times root 7. Root 28 we can rewrite as root 4 root 7. And root 63 we can rewrite as root 9 root 7. So all in all, that entire expression can be rewritten as root 100 root 7 plus root 4 root 7 minus 2 times root 9 root 7. Well, luckily, all of these terms before the root 7 have nice integer values. So root 100 is 10, root 4 is 2, and root 9 is 3. So we have 10 root 7 plus 2 root 7 minus 2 times 3 root 7. So working this out, we get 10 root 7 plus 2 root 7 minus 6 root 7. And this will simplify to 6 root 7 in total. So question 7, we have write 5 over 2 plus root 3 in the form a minus b root 3, where a and b are going to be integers. So hopefully you managed to answer that okay. How do we go about working this out? Well, using our rationalizing the denominator rule. So we're going to take that denominator and we're going to multiply it by the same denominator but with the opposite operator in between. So we have 2 plus root 3 on the bottom. So we're going to multiply through by 2 minus root 3. When we do this, we get 10 minus 5 root 3 on the top. And on the denominator, we're going to get 4 minus 2 root 3 plus 2 root 3 minus 3. So the middle terms cancel out, and we just get 10 minus 5 root 3 over 1, which is just 10 minus 5 root 3. So I think I've saved probably the trickiest question for last. So we have write root 6 plus root 2 multiplied by root 6 minus root 2 divided by 2 minus root 2 in the form a plus b root 2, where a and b are going to be integers. So a little bit of advice with this one. You've got all the rules there to work this out. Just take it step by step. Pause the video when you're ready and then come back when you want to hear the answer. So how do we go about answering this one? Well, let's start with the brackets. So we have root 6 plus root 2 times root 6 minus root 2. A good place to start would be to work out the value of this. So expanding this bracket, we get root 6 plus root 6 root 2, and then minus root 6 root 2, and then minus root 2 root 2. So we can simplify this. So we can simplify this. Root 6 is 6. The root 6 root 2 terms cancel out. And then root 2 is just 2. So we have 6 minus 2 is just 4. So now we can rewrite this question. So we can rewrite this question as 4 divided by 2 minus root 2. And now you can use your knowledge of how to rationalize the denominator to work this remaining part of the question out. So to do this, we've got the denominator 2 minus root 2. So we're going to multiply top and bottom by 2 plus root 2. When we do this, we get 8 plus 4 root 2. And then in the denominator, we get 4 minus 2 root 2 plus 2 root 2 minus root 2 root 2. Simplifying this gives us 8 plus 4 root 2 over 4 minus 2. And this simplified is 8 plus 4 root 2 over 2. And then our final answer, when we divide through by 2, we get 4 plus 2 root 2. So thanks for watching. Hopefully you enjoyed the video and learnt something today. If anything is unclear or you have any questions, leave a comment and we'll get back to you as soon as possible. If you haven't already, please like and subscribe, and we'll see you at the next one.